With our feet now firmly planted in the nonlinear universe, we continue with intensity transformations. First up, CurvesTransformation, a tool for adjusting the brightness, contrast, and color properties of an image. With a foundation in histogram transformation, the curves dialog looks somewhat familiar. In the default edit point mode, you create curve points by clicking in the curve editing area. We recommend leaving the grid on. Click on an existing point and drag the cursor to change its position. In select point mode, choose an existing point for read-only analysis. This can also be done here. Use delete point mode to delete unwanted points with a click. The easiest way to zoom into and out of a curve is with the mouse scroll wheel. You can reset zoom levels here. Refer to the help file for additional zoom commands and available keyboard shortcuts. Here we're offered many channel selections, giving us the ability to access the data via different conduits. As in histogram transformation, here are the combined RGB gray channel and individual R, G, and B color channels. Note too that several others are available, including several lab components and finally saturation. They are well documented in the help file, and we'll cover several of them later. While all are significant, this, very importantly, gives us access to the lightness component of color images, and it is here that many PixInsight users choose to perform color saturation. If you make adjustments to more than one channel, you can choose to show all curves at once by toggling here. The default Akima subspline interpolation is appropriate for most situations. You can store a curve for later use in a session or restore a previous curve. As do several other processes, CurvesTransformation offers an invaluable real-time preview mode. As with histogram transformation, CurvesTransformation can read information generated by the cursor in readout mode. This aids in deciding on the placement of control points. Reminiscent of Ron Wodowski's Photoshop-based zone system, you can measure, then place points relating to the brightness levels of shadows, midtones, and highlights to fine-tune the image. Though we chose not to use CurvesTransformation for our initial nonlinear stretch, shapes such as the standard curve can certainly be formed, as can simple gamma boosting or reducing shapes. Here, I apply a classic S-shaped curve to enhance contrast. More complex micro-contrast curves can also be applied locally using a mask. We'll return to CurvesTransformation later in the series. Next up is a process designed expressly for use on nonlinear images. Local histogram equalization is an extremely powerful process and may be apropos of this stage of the workflow, and can transform a good-looking image into a spectacular one. Easy to use, LHE enhances visibility of structures in regions of low contrast. LHE computes a transfer curve, which brightens histogram peaks while darkening its valleys. Simply put, large areas of similar brightness levels get more contrast. We'll see how it's done in the next lesson.